Hello, my name is Giancarlo and I'm part of team number 5. We were given a special study case in order to apply the DMAIAC methodology for 6SIGMA. This case is about Microtronic Inc., a company dedicated to the production of scan engines for applications in retail and manufacturing. One of their products, Model X2001, was reported to fail by inspections, killing in approximately 7,000 defects per million units sold. A root cause analysis shows that the error surges from the Mylar motor, a scanning element that processes information. This analysis proved that the reason why the motor is failing is due to a weld joint that may not be passing force and impurity analysis requirements. Using 6SIGMA methodology, the goal is to give recommendations in order to reduce the defects and improve the overall process. We performed a Pareto analysis among all the models of the company, and the Pareto analysis showed that model X201 is the perfect case in order to improve the process. Also, the process sponsor is defined as the leader who sponsors a specific project.
So hi, I'm Hibran from Team 5 and I will talk about batch rate. We take a sample of 60 pieces that were evaluated in shear force and metal flow index in difference. So for this part, we first do a histogram, and we noticed that the behavior of this histogram was not normal distribution. That's why we can't use the DPMO, and we instead use the DPM. The DPM test came with an example of more or less 300,000 pieces, and then after that, seeing that this behavior was not normal, we realized that this sample was divided by 3 main patches, patch 1, patch 2, patch 3. We analyzed each one of these and we saw that the patch 1 was the one having a normal behavior, patch 2 and 3 were having more different behavior, special cause variation. We also see that the relation between the stretch force and the melt flow index was decreasing, saying that it more or less was indirect, saying that one go with a higher value, the other one will have a less value. This was shown in a scatter plot distribution.
I'm going to talk about one of the most important steps in the DMAIAC process, which is analyze. In this step, we can find the amount of improvement that might be possible. Actually, we focused in the 100 recent production sample. Once we obtained the process information, we analyzed the shear force first. In this one, we could appreciate a normal distribution in the histogram. However, by analyzing the control charts, there are 5 points out of control limits. Consequently, it is complicated to obtain the process capability. On the other hand, there is the material impurity histograms, which shows like a normal distribution, and also by analyzing the control charts, we identify that the process is in control. Consequently, we can analyze and we can obtain the sigma level, the total DPMO, and finally the percentage of defective products.
Hello, I'm Andrea and I'm going to talk about the part of seeking to improve the process. We could find an area of opportunity to attack the problem to use within the Pareto diagram, which is the total cost of reducing failures. If we reduce the number of failures associated with our model, the company could save a lot of money. So, on the other hand, in the part of implement, we must determine what caused the variation and make sure it doesn't happen again in order to have the process in control and try to have more special causes on the future. We need more information on the process and more testing as well as full knowledge.
The last part of the DMAIAC process is control. This step is very important because this makes sure that defects will be reduced in the future and that they won't happen again. By this, we will standardize the process to ensure that the mistakes in the past won't happen again, and what we implemented in this 6SIGMA project will continue through time, and this will help for the 6SIGMA project not to get lost in time and not to to continue it from happening, especially the special causes.